All right, we have an observer 70 meters south of a railroad crossing, watching an eastbound train traveling 6 meters per second. Before I read the rest, let's just picture this. If this is the, excuse me, the crossing point, the observer is 70 meters south. So this is where our observer is, and 70 meters south. The train is going eastbound, so never eat soggy waffles. East is to the right. I don't know if you guys still do that, but I for sure do. Traveling at 6 meters per second. So, oops, sorry. There we go. That is a dx dt value you are given because it's talking about the train's movement. And we'll just do this little train. How many meters per second is a train moving away from the observer after 4 seconds? So what it's saying is if it's moving away from the observer, we're picturing this right here. And it's saying how fast, well that's a rate. So what it's actually asking is the change in the hypotenuse compared to time. The person, this is a constant here. So I'm going to star the constants in the problem. That's really important to note. The distance the train is getting away in the x direction is changing. The distance, the hypotenuse as the train changes is also changing. So those two, I know it says, we're just assuming the man did not move. So 70 is truly the only constant here. Seeing that there are no angles this is discussing, we can see this as a Pythagorean theorem problem. But it almost seems like we don't have enough information because if we take a look, we're told after 4 seconds, well, none of our sides are in seconds. It's talking about meters in all 3 directions of the triangle. But that's where this piece of information, this is not only dx dt, it is also telling you that if it's traveling 6 meters per second, that rate times 4 seconds, this is a unique way of saying that this side of the triangle is 24 meters. The 6 meters per second times the 4 seconds makes that side 24 meters. So again, that 24 meters is just an instant in time. It is not a constant. So this is the whole setup for the problem. Now, if we want to find how many meters per second, or the dH dt, that means we have to derive our Pythagorean theorem. And this is where the constant is. That's our y value. So actually y is going to be 70 squared here because we can plug in constants into our problem, and we know that constants derive to 0. And then when we derive this side, this makes sense because if we're talking about how far the train is moving away from the excuse me, away from the observer, that is the change in the hypotenuse. So now that we have it in its derived form, hopefully now you're like, all right, I see how to plug things in. So feel free to pause the video and try the rest of this on your own. I'm going to pause it here and put out the rest of the answer so you don't have to hear me talking through how I'm substituting. But go ahead and try it on your own and then play the video. All right, here is the rest of the problem. After you substitute, you did have to do Pythagorean theorem to find out what the hypotenuse was. And then from there you could find that the train is traveling away from the observer at a rate of 1.946 meters per second.